Hello class, today we'll be looking at 5.3, evaluating trigonometric functions. So in this section, we're going to be looking at right angle base definitions of trigonometric functions, cofunctions, trigonometric values of special triangles, and we're going to be looking at finding values using the calculator and finding angle measurements. So when we talk about right angle based definition of trigonometric functions, it says let A represent any acute angle in standard position. We have the sine of A is equal to what? Y over R, which is the opposite over hypotenuse side. Then we have cosine is equal to the adjacent over hypotenuse side. Then we have the tangent of A is equal to the opposite of A over the opposite over adjacent side. Then we have cosecant is equal to hypotenuse over opposite. Then we have hypotenuse. Then we have our secant is equal to hypotenuse over adjacent. Then we have cotangent is equal to adjacent over opposite. So maybe if you heard certain sayings, so if you ever seen it, so it's S-O-A, O-H, C-A-H, and T-O-A. So SOHCAHTOA, which means what? Sine is equal to opposite over what? Hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So you may have seen this before. If you have not, then make sure you write it down. This is the easiest way to remember them when you're going through them. So let's look at this right here. So we have a problem. Yeah, I'm going to change colors. It says what? It says find sine, cosine, tangent of value for values for angle A and B. So we're just looking for sine, cosine, and tangent. So I'm just going ahead and find the sine of A. So the sine of A is equal to opposite, so this angle here, and we're looking at the opposite side of A, which would be 7, over your hypotenuse, which would be what? 25. And let me go ahead and do the cosine of it. So the cosine of A is equal to what? The adjacent, which is 24, over the hypotenuse, which is 25. Now, tangent of A is equal to what? Opposite, which is 7, over the adjacent, which is 24. So 7 over 24. So for my cosine, my sine of B, I know that I'm looking at what? A, I'm looking at B, which is here. So my opposite changes to what? This is my opposite side, and this is my adjacent side now. So it'll be what? 24 over 25. And then cosine of B would be what? 7 over 25. Then my tangent would change, right? So instead of 7 over 24, it'd be what? 24 over 7. If you notice, the sine and cosine switch when you change with a different angle, because the opposite and the adjacent side switches. Make sure if you have any questions about these, you make sure you hit me up on Microsoft Teams or you email me. So with these cofunctions, we have to look at what we got. So it says for any acute angle A, cofunction values of the complementary angles are equal. So the sine of A is equal to what? 90 minus A. It's equal to what? The cosine of 90 minus A. The cosine of A is equal to sine of 90 minus A. Then we have what? The tangent of A is equal to the cotangent of 90 minus A. Then the cotangent of A is equal to tangent of 90 minus A. Secant of A is equal to what? Cosecant of 90 minus A. Then we got cosecant of A is equal to what? Secant of 90 minus A. So just keep that in mind. So when we do some of these, and we're about to do a few of these, I mean, just understand that they're complementary angles and they're equal to each other. So looking at this problem, this is equal to what? Sine of 90 degrees minus what? 52 degrees, right? Therefore, this is just equal to what? The sine of 38 degrees. This one is equal to what? The cotangent of 90 degrees minus 71 degrees. So this is just equal to the cotangent of what? 19 degrees, right? And then the same thing here, we got what? Secant of 24 degrees is equal to the cosecant of 90 degrees minus 24 degrees. And that's equal to what? The cosecant of 66 degrees. And it doesn't matter if you have the parentheses or not, but just knowing that it's in parentheses. So now let's look at our special triangles. We have our 30, 60, 90 triangle, then we have our 45, 45, 90 triangle. Now, with these, if you look in the box, they come from what's on your special triangles. So if I was looking at the sine of 30, which we know that 30 is where? 30 is right here. If we look at what? Opposite over hypotenuse, which opposite will be here and the hypotenuse will be here. So opposite over hypotenuse will be 1 over 2. That's how they got 1/2. If we look at the next one, sine of 45. Now, it doesn't matter which 45 you're using, all right? Because you can use this one or the other one because both sides are the same. This is the opposite side of that 45. You do what? You do opposite over hypotenuse. Now, you know you'll get the 1 over the square root of 2, and you know that equals what? The square root of 2 over 2. And it follows throughout your whole thing, all right? So just keep that in mind. So the more you know of this, the better off you will be. So let's look at reference angles. A reference angle from an angle theta is the positive acute angle made by the terminal side of the angle and the x-axis. Remember, it's to the x-axis, not to the y-axis, always to the x-axis. So if you're in the what? Second quadrant, it's to the what? Negative x-axis. If you're in the third quadrant, it's still to the negative x-axis. If you're in the fourth quadrant, it's to the what? Positive x-axis. So your reference angle is always there. All right, so keep that in mind when you're going through these problems. So let's look at one. So it says the reference angle for angle 218. So let's look and see where it's actually at. This is your y, this is your x. Now, I'm about to use a different color. So coming from, I know that when I get to this line, I'm at 90, 180. Now I need to go, how many more? 30 more. So the angle from here to here would be what? 30 degrees. So my reference angle would be what? 30 degrees. All right, so theta prime is equal to 38 degrees. So it should be 38 degrees. All right, because we have to go 38 more degrees to do what? Get to that spot. Because if we look, we got what? 218 minus 180 degrees, because remember, that's 180 degrees there, and that equals 38. So keep that in mind. We had to go 38 more degrees. All right. So our reference angle is 38. Let's look at the next one. All righty. So, which is the y, this is the x. Now, with this, we just kind of want to see what we have. Now, we know if we go around twice, we at 7, what, 20, right? We're at 720 when we go around twice. Now, let's go around one more time. Where are we at then? So basically, we went around, and let's add this up. So we got 360 times 3, which gives me 1080. So that's 1080, and I need to go how many more? So I do what? 1387 minus my 1080. I need to go 307 more. So to go 307 more, I would go all the way around till I get to here, which is 270. Then go how many more? 37 more, right? Now, but when I do this, I have to keep in mind when I draw my reference angle go from what? From there to here. Because you always make your reference angle from your what? To your x-axis. So now we're going to get what? 360 minus my 307 degrees. And that's going to give me how many? 53. So my reference angle would be 53 in this case. So my reference angle, which is theta prime, would be 53. So just keep that in mind. Now, another thing you could have just did was just look. You knew you was going to end up in what? Quadrant what? 4, right? So you knew that what? The next number, the next x axis, which would be a 360. So just do 360 minus whatever you have. Once you figured out how many more you had to go. All right, so keep that in mind. So we have what? Theta equal to 53. Now, basically, this is what I was just saying. If you're in the first quadrant, theta prime is equal to theta. If you're in the second quadrant, you do what? 180 minus theta. If you're in the third quadrant, you'll do what? Theta minus 180. You're in the fourth quadrant, you do 360 minus theta. So that's exactly what I was saying a second ago. So remember that anytime during this, you can always pause, the video and then copy whatever you need to copy. So find all 6 trig functions for what? 210. Now, we think about 210. We have the y and the x-axis. Now, we know that we go 180, then we go what? 30 more. All right? Now, we know that we got what? 210 minus 180 degrees, both from degrees, and that equals 30 degrees. All right? So basically, now we have to keep in mind what we're doing. We're looking for what? The sine, cosine, tangent of 2tan. Now, the thing is, we know that certain ones are negative. We know that sine is negative and cosine is negative. All right? So, the cosine of 2tan, the sine of 2tan, and let's see, we got the tangent of 2tan. All right. Which this is equal to negative cosine of 30. And this is equal to negative sine of 30. All right. And this is positive. All right. So then we got what? Cosecant of what? 2tan. And we have what? Secant of 2tan. Then we have cosecant of 2tan. Now, if you remember in your previous slides, we talked about what the sine, cosine, and what tangent was of this. So if we look at cosine of 30, it was what? The square root of 3 over 2, but it'd be negative square root of 3 over 2. Remember, the sine of 30 was 1/2, so it'd be negative 1/2 because we're in the what? Third quadrant. Then when you put the two together, you will get what? You'll get negative. Well, negative of negative is positive, but you'll get the square root of 3 over 3 for what? The square root, the tangent of 30. Now you have to do what? You have to flip these. But what we're going to have, we still going to have what? Negative. Still going to be negative because sine is negative. So cosecant will be what? 2. And cosine will be what? Negative 2 times the square root of 3 over what? 3. Because it's going to be 2 over the square root of 3, then you got to rationalize it. And your bottom one is cotangent. Sorry. It should be cotangent. All right. Cotangent is just the flip of the other one. So that'd just be the square root of 3 for the cotangent of 2tan. All right. So these is all 6 of your trig functions. Make sure you change this one on the bottom because it was what? Cotangent of 2tan, not cosecant. I already got cosecant. All right, so let's look. So let's look at this. It says find the exact value of cosine of negative 240, cosine of negative 240. So let's look at this. So we're looking at negatives. We know that we're going clockwise. So we go start here and we will go around. Then we go here, we get to what? Negative 180. Then we go how many more? 60 more. All right, so we know that this is 60 degrees. Now, in this case, cosine is what? Negative in the second quadrant, right? So just keep that in mind. So let's look at this. So the cosine of negative 240 is equal to minus cosine of 60. All right, which is equal to, now this is equal to negative 1/2. So if you look at your special triangles, you can figure out what the cosine of 60 is, and then since we're in the second quadrant, it makes it what? Negative. So it'll just be negative 1/2. So let's look at this. The exact value of tangent of 675. Now, we got the y and we got the x-axis. Now, that means we done went around this thing once. Then we went around it how many times? We went around it this way, then we went 270. Then we went how many more? 45 more. But the thing is, we know that from here to here, it's 45 degrees. Now, we're in the fourth quadrant, so we know that tangent is negative in the fourth quadrant. So if we look at the tangent of 675, is equal to what? Negative the tangent of what? 45 degrees, which that equals to negative 1. So keep that in mind. And this is how you show your work. You draw out the XY axis and you show how many times it go around, all right? So just keep that in mind. So now it says find all values of theta if theta is in the interval from 0 to 360 and cosine of theta is equal to negative square root of 2 over 2. So we're basically finding the what? The values, right? So let's look at this. Now, personally, if we're looking for the values, we know that they can only be in 2 quadrants. All right? We know they can only be in 2 quadrants. So if you look back at what you have, now the square root of 2, negative square root of 2 over 2, or anything of that nature, we know we're dealing with 45-degree angles. Because if you look at your special triangles, if we do the cosine of 45, it gives us what? The square root of 2 over 2. All right? So we know we have a reference angle here of 45 degrees. Now, but the thing is, we got a reference angle right there of 45 degrees. That means our angle has to be something here. Now, that would just be 180 minus my what? 45. Which that just equals 135 degrees. So, and that's in quad 2. All right? So you know that theta equals what? So this theta equals 135 degrees. Now we should have another one in this one that makes a reference angle of 45 degrees. So all we got to do is do 180 plus 45 to figure out what that angle is, which it should be what? 225. And that's in quad 3. So our second one is what? 225. Now, that's the only one that's left because we're dealing with the x. We're dealing with cosine, so that deals with x's. and x is not negative any other quadrants but 2 and what? 3. So we found our values that we needed. If you have any questions, just let me know. So let's look. Now with these, it says use a calculator to find an angle in the interval from 0 to 90 that satisfies the conditions. Now, all you got to do is do the sine inverse. So here, we're looking at theta is equal to the sine inverse. So using on your calculator, second sine of 0.96709.5. So if we were to go put that in our calculators, and I'm going to go put it in mine. Let's see, we got, so a second, let's make sure we're in the right mode. We should be in degree mode. All right. So we have second sine, which is good with sine inverse, of 0.96770915. All right. And it gives us roughly and I'm going to round this a little bit. So it's 75 point, and I'm going to just say 75.3999995. All right, degrees. Now, and you just put that in the calculator. Now, this one is a little tricky because first you need to do is put it in terms of cosine. So we know that cosine of theta is equal to 1 over secant theta. So this is equal to 1 over 1.0545, erase that, 829, right? Now we have to do what? Theta is equal to the cosine inverse of that 1 over 1.0545829. That's how you have to put in the calculator to get your correct answer. And you'll see that theta would be what? 18.514704 degrees. You might have seen some of these in your homework assignment. Now, make sure if you have any questions about 5.3, you make sure you contact me.